guys first and then throw you guys in the mix with everybody else. Oh yeah, for sure. I've got the whole shebang. I've been collecting. This one's fun.
Besides your collected data, do you have any outside?
I've got Dr. Mark Eberle's as well, but he stopped collecting it for some reason. I don't know why. He doesn't do it anymore. Has anybody done this experiment in Dr. Mark's class? I forget which class it's even in. One of his A&P classes, I think. Nobody's done it with Dr. Mark? Yeah, he's the one that got me thinking about this, because he sent me the results and he said, can you prove anything from this? I'm like, well, I can support it. I can't prove anything. He's like, okay, stat dude. But then we got into it. It was kind of fun. So anyway, okay, so we got ourselves a histogram. Well, there it is, somewhere. Next question. Do we have any outliers?
No.
Doesn't look like it, not by the mathematical definition of outlier. We've got tails of our bell curve. You would call that a bell curve, wouldn't you? Now, this is one thing. When you run t-intervals, you generally want to be roughly bell-ish. Roughly bellish. I want to leave that as a very, very vacuous statement, roughly bellish. You want to avoid crazy deviation from bell curve data. Also, you definitely want to avoid outliers. Okay? The second point, number 8 there, how did you check? You could put in there, Sean drew a box plot if you want. And it was a modified box plot, just so you know. Just so you know, it is a modified box plot, but you can also do your old 243 move. Oh, go ahead, Ben, go ahead.
I'm just trying to remember the calculation.
That's okay. Don't worry about the calculation. Watch this. Here's how you do it. Here's the calculation with my fingers. Remember what this is called? This distance? Remember what this distance is called? 3 letters. IQR. You got it. You got it. You remember, it's the IQR. That distance multiplied by 50%. You stack that on the quartiles like that and like that. If anything gets outside of your outside fingers, they're called outliers. Now you did that like 6 months ago with me, and you've totally forgotten it since then. But now it's on video, you can look at it again if you need to. But that's the IQR calculation, 1.5 times the IQR plus or minus from the quartiles. But we're good, there are none, right? Nothing's over here. Nothing's over here, no outliers. No outliers to speak of. There are high and low values, but they're not unusually high or low values. So that means the person that got 1 and the person that got 9, they're the min and the max of our sample, but they're not unusually large or small based on that. Is that fair? Hopefully that's fair. Good. Okay, beautiful. Why do we care? Number 9. Why do we care?
Why do we care what?
Why do we care about, well, he said, why are there outliers? How did you check? Why do we care? Because
It'll pull the graph one right direction.
this is a concern with averages. When you have extreme outliers, or any kind of outliers, the average is going to chase the outlier. This is why when you guys mentioned your result, you got to watch those. And Sean, when you said, we found a psychic, I'm like, or we found somebody who found a hole in the experiment. But you got to watch those outliers because the average is going to tend towards those. Now, if the data came back looking like this, then we quit our day jobs.
No, that would just say that multiple people are psychic.
Yeah, everybody.
Just that you found one outlier would mean that you would do more experimentation on that one individual.
That's the important thing, right? You find out why that one person could do it.
Correct.
And this is what's interesting. I'm glad you brought that up. So, who's seen Ghostbusters? I know this sounds ridiculous, but I swear to God it ties back to it. The opening scene of Ghostbusters, if you haven't seen it, I'm going to spill the beans on the opening scene. Bill Murray, bless him, genius, is doing an ESP test on 2 of his graduate students. I think they're maybe they're undergrads. A really cute young lady and a guy chewing gum. And it's an ESP test. If you've never seen an ESP test, it's a series of 5 cards with symbols on them. One's a star, one's 3 squiggly lines, one's like a square with a dot in it or something, right? And the idea is he holds up the card facing him, and he asks the respondent what's on the card. And the funniness of the movie is he always says to the cute girl, you're right, you're right. And he always says to the gum-chewing guy, you're wrong. And the funny part is it's shock therapy. He shocks you if you get it wrong. He's testing the theory that negative reinforcement, I love Bill Murray, negative reinforcement negatively correlates with IQ. So as you keep negatively reinforcing, it's lowering his IQ. Anyway, great movie if you haven't seen it. The funny part about it is a study was done years and years ago that was then overturned. They found a dude who was nailing the ESP way more than 20% correct. Because you would assume if you're guessing, you're going to be right 20% of the time. There's 5 cards. You're going to be right 1 in 5 or 20% of the time. Well, this dude was getting like 65, 70% right in repeated trials. He would do it once and get 70%, he'd do it right, get 70, 65, 75, and they're like, holy crap. And it had a nickname for him, which I've now forgotten. Well, what happened was eventually he started reverting back to 20. It's just that he was an outlier repeated times, which happens even less than a normal outlier occurrence, but it does happen, just not that frequently. So high IQ something, he had like a nickname in quotes. But it happened, and they were trying to figure out, is it just random chance, or is this guy actually seeing something and it was just random chance? It just so happened, it was like taking a pair of dice and rolling double sixes like 36 times in a row.
Yeah, it's when you're hot.
It's, or when you're lucky. Right? Oh, you said the same thing though.
Yeah.
We're saying the same thing, right. Whenever I hear that, I'm like, ugh. But it's gotta happen sometime.
Yeah.
It's gotta happen sometime. It just happened then in a study and it was observed. Does that make sense? And it goes to show you how often that happens and we're not observing it. I mean, you know, playing Monopoly with my son, watching the dice roll. I mean, playing last night, he bought the 2 dark blue squares on successive rolls. He landed on, I forget what it's, Park Place and Boardwalk. And he rolled the double 2 to get the Boardwalk after he landed perfectly on that one. I'm like, it's gotta happen. It's gotta happen eventually, right? So, thank you for that. Perfect. All right, so we care because the outliers can be meaningful, but if they're just strictly outliers, random chance outliers, we don't want to put too much weight on those. They're unfairly weighted in the average. Why didn't we check for outliers when we were doing confidence intervals on proportions? It's a bit of a trick question, honestly. Because they're proportions, and there's no such thing as an outlier because an outlier ties to the average. An outlier is defined to be a certain distance away. That's how we just, oh, it's off now. That's how we measured the outliers here, right? We measured them with our fingers. We said this, and then we did this, right? Distance does not exist with proportions. Proportion is a yes or a no. It has that characteristic or it doesn't. No such thing. No such thing as an outlier with proportions. Is that believable? Hopefully it's believable. You guys okay with it? Maybe. I'm going to take your silence as consent. Okay. Maybe. Okay. Now, here we go. Let's crunch it off. Let's actually make the t interval based on this data. Now, we're not going to go ahead and crunch it by hand. I can't stand that stuff. We're done with that t interval crunching stuff. Let's use the built-ins to do it. Let's use the built-ins to do it, all right?